Science is not about thoughts, feelings, wishes, and fantasy. Scientists don't attribute their findings to numerologists, psychics, or forces beyond human understanding, although quantum physics has some funky stuff. Science is about examining reality in an objective way, drawing conclusions from evidence or observation. When scientists conduct experiments, they use different methods to understand a problem. For instance, a scientist could use inductive reasoning, which is drawing conclusions from evidence, or deductive reasoning, which is finding evidence to support or disprove conclusions. Let's make this a little more clear with some examples. Inductive reasoning is the more common way that scientists conduct experiments. Scientists have an idea of something to study more in depth. Then they go and collect data through experiments, observations, or surveys. With all of the data in hand, they analyze it to draw out conclusions. Inductive reasoning is about collecting data and seeing what patterns or meaning can be extracted. A researcher, let's say you in this example, was taking a test and noticed that this fly kept buzzing around. It buzzed around your head and it was distracting you. So you wondered if noise distraction has any effect on test taking. You will then set up an experiment involving 100 people taking a test with some noisemaker in the background. The people will be divided into 5 groups of 20, and each group will have a different level of noise, from quiet to obnoxiously loud. After all 5 groups have completed the tests, you will compare their different scores to see if there was a difference. If the scores typically grew steadily worse as the noise increased, then you could draw a conclusion that as distractions increase, test scores will generally decrease. If, on the other hand, the majority of the scores increased with the noise, then you would make the correlation that, as distraction increases, test scores will generally increase. To reiterate, inductive reasoning draws conclusions from evidence. Deductive reasoning and methodology is not as common as inductive reasoning with psychological scientists. Deductive reasoning usually happens when a researcher observes something and believes it to be a common response. The researcher will then develop a theory or conclusion and then work to find evidence that supports or dismisses it. The reason this type of reasoning is not as commonly used as inductive reasoning is the risk of only looking for research that supports your conclusion. It's all scientific, but it has a higher probability of going awry. Let's say every time you run the experiment with the noise making and test taking, you find that as noise increases, the test scores decrease. Your observations, however, indicate that 2 or 3 people per group do substantially worse in quieter conditions, but extremely well in very noisy conditions. When you look at their demographic information, you see that most of them admit to having attention deficit hyperactive disorder, or ADHD. With your observation, you develop the conclusion that individuals with ADHD have an opposite reaction to noise compared to those without ADHD. To confirm or disprove your conclusion, in the next round of test taking, you select a higher number of individuals with ADHD and compare their scores to those without. As a researcher, you created a conclusion about the effect of ADHD on test taking. You then collected your evidence that would support or disprove your conclusion. Your evidence indicates that there is no connection between ADHD, test taking, and noise levels. The conclusion was proven false. Deductive reasoning is having a conclusion and then testing your conclusion to prove or disprove it. Inductive reasoning is drawing conclusions from evidence. This means a scientist collects data and interprets it. Deductive reasoning is finding evidence to support or disprove your conclusions. This is where a scientist has an idea and then tests it to see how correct it is.